I was sitting in a cafe in Palo Alto last week, and I was with a guy who spent, the last decade coding for a major self-driving firm. He was leaning over his espresso, practically, vibrating with intensity as he walked me through this moral dilemma his team was stuck on. It was the classic trolley problem. If the car has to choose between hitting a group of school kids or swerving into a wall and killing the passenger, what does the code do? And he talked about it like it was the ultimate philosophical hurdle of our age, a gatekeeper standing between us and the future. He seemed almost proud of the complexity, as if the deadlock itself was a sign of civilizational maturity. But then I pulled up a news alert on my phone. Beijing had just issued the first batch of official road test licenses for Level 3 autonomous driving. Not for a closed track or some limited simulation, but for the actual high-density streets of a mega city. I watched his face as he read the headline. The excitement about the trolley problem just evaporated. He didn't ask about the sensors or the compute power. He looked out the window at the cracked pavement and the tangle of local construction permits outside, and he just whispered, "How did they get the liability framework settled so fast?" And that's when it hit me. While we are over here debating the ethics of hypothetical accidents and drowning in a plutocracy of legal hearings, environmental lawsuits, and local protests, another system has already finished building the physical skeleton for the next century. That license plate in Beijing wasn't just a piece of metal. It was a dimensional demotion of our entire political process. It's the difference between a society that spends its energy on redundant code, these endless arguments that just lead to gridlock, and one that treats infrastructure as the very flesh of modernity. It's not just a lead in AI. It's a display of state capacity that makes our San Francisco debates look like a high school drama club. It forces the question, is our obsession with absolute safety actually just a sophisticated way of choosing to stand still?
That story it's the perfect lens for this deep dive. Our mission here is to move past the surface level tech differences and really explore the profound contrast between governance systems. So on one side, you have those that prioritize progress through massive implementation. And on the other, systems that are just. They're so constrained by preemptive debate and regulatory fragmentation. We're really looking at the foundational political and engineering choices that either accelerate or just halt technological transformation. And we've identified really 3 fundamental structural insights that underpin this whole comparison, showing how infrastructure policy and scaling are all intertwined. First, you have the strategic and, frankly, rapid implementation of V2X smart road infrastructure in major Chinese cities. This just shows so clearly how high-stake capacity and centralized urban planning can decisively overcome the kinds of fragmented private property rights and legal hurdles that, currently paralyze autonomous vehicle deployment in Western urban centers. The ability to just mandate standards and build quickly completely changes the competitive landscape. And second, when you analyze the resulting efficiency of East Asian governance in accelerating the commercialization of Level 3 or L3 autonomous driving, you see this significant global shift. Technocratic long-term planning is successfully bypassing the democratic gridlock and, frankly, the litigation-heavy environments that really characterize the West's approach to technology adoption. When the state establishes a 20-year plan, it provides an unparalleled framework for industrial investment. And finally, the rapid regulatory approval and the sheer industrial scaling of L3 autonomous driving in China, it serves as a definitive indicator of a major power shift. We are witnessing the rise of what you could call engineering-centric civilizations that prioritize tangible, measurable technological progress kilometers of smart road, units deployed, cost savings over the abstract ethical debates and regulatory inertia that define the post-industrial West. And that difference in prioritization is now manifesting as economic dominance.
Okay, let's unpack this. I want to start with the very foundation of this divergence. The regulatory and infrastructure divide. When we talk about autonomous vehicles or AVs, most people instantly think of the complex algorithms, right? The LiDAR, the sensors. But what you realize when you dig into the data is that the most significant factor differentiating deployment speed isn't the chip. It's the cement and the unified policy framework that governs how you can even apply that chip.
That's a crucial distinction. The China model is built on this cohesive, unified policy that basically mandates speed and integration. And this is all made possible by highly centralized oversight. Just look at the drone sector. The Civil Aviation Administration of China, the SHAEC, handles all drone regulation for the entire nation. This kind of structure is just inherently accommodating to commercial applications because it provides one single, clear regulatory roadmap.
So if you're a logistics company, you don't have to negotiate airspace access with every single provincial government.
No, you just follow a national standard.
And that standard is designed for rapid adoption, right? It's not just about tolerating innovation. It feels like aggressive enablement. We see the government actively backing development through direct funding, establishing these massive designated testing zones, and implementing policies specifically designed to fast-track research and commercialization. It's industrial policy, but applied to the sidewalk in the sky.
And the measurable output of this centralized policy is just staggering. By 2023, China had officially issued 16,000 operational licenses for autonomous vehicles. And that figure isn't theoretical. It represents actual deployment on designated routes within specific commercial frameworks.
16,000.
This level of direct governmental facilitation allows companies of all sizes, from startups to massive enterprises, to move from prototype to commercial operation incredibly fast. This unified environment is so critical for scaling technologies across dense urban centers and into less developed rural areas all at the same time.
Okay, so now let's flip that lens and look at the U.S. model, where fragmentation seems to be the defining characteristic. For ground vehicles, the regulatory oversight is. It's an absolute nightmare of complexity. It varies wildly by state, county, and a lot of times even by municipality. A company trying to roll out an autonomous delivery fleet nationwide is tackling what? Potentially 50 or more different legal and regulatory regimes.
All with varying standards for safety, for permitting, for certification. It's a patchwork.
And this patchwork of laws doesn't just inconvenience the big corporations, does it? It must fundamentally stunt the growth of the whole ecosystem.
It absolutely does. It's a major economic hurdle for small and medium-sized enterprises, for SMEs. I mean, a large player like Amazon can afford dedicated legal teams to navigate those 50 state laws, but an innovative startup that's focused on local delivery just can't. They get bottlenecked by inconsistent infrastructure and this crushing regulatory uncertainty, which just limits their ability to capitalize on any cost reductions.
And even where you do have federal oversight, like the FAA for drones, the process is still slow.
Exactly. The certification processes are often complex and very time-intensive, which just slows down the time to market compared to the rapid iterations we're seeing in China.
So the most profound evidence of this policy difference is the physical stuff, the infrastructure itself. China really adopted a strategy of building the digital skeleton first, recognizing that the vehicle automation is useless without the underlying network. And this meant massive, coordinated investments in urban planning, comprehensive 5G networks specifically designed for vehicle communication, and designated AV zones.
And this brings us to a really crucial technical concept that explains why centralization is so effective here. V2X, vehicle-to-everything communication.
V2X.
Yeah. V2X is the ability for a vehicle to communicate seamlessly and instantly with traffic lights, with road sensors, utility grids, and of course, other vehicles. For V2X to work reliably and to scale, you need massive unified standards. You just do.
And China's centralized planning allows them to just deploy these standards across major cities all at once.
Right. They're integrating the physical and the digital infrastructure from the get-go.
And the numbers. The numbers defining this infrastructure readiness are just astonishing. China's surge in AV-ready roads, and that means roads equipped with those V2X sensors and 5G connectivity, went from a mere 1,000 kilometers in 2018 to a staggering network of 35,000 kilometers by 2024. That is a 5-year mandate executed on an exponential scale.
And to put that number, that 35,000 kilometers into perspective for you, that is roughly the distance from Lisbon, Portugal, all the way to Tokyo, Japan, and back again.
Wow.
We are talking about building a foundational national asset that far, far exceeds the typical regional or city-by-city pilot projects we see elsewhere.
So now let's compare that to the U.S. picture. Despite all the rapid technological development, infrastructure growth here is fragmented. U.S. AV roads grew substantially. From 500 kilometers in 2018 to 10,000 kilometers by 2024. That's a 20-fold increase, which shows huge private sector interest in innovation. But 10,000 kilometers is still less than 1/3 of the ground China has covered.
And the disparity isn't just in the total length, but in the efficiency of deployment. If you look at the infrastructure growth per percentage point of AV adoption, China is building approximately 2,000 kilometers of smart road for every single point of adoption increase.
Wow, 2,000 kilometers per point.
It's significantly higher than the comparative rate in the U.S. This just confirms that centralized urban planning doesn't just make it easier to build, it makes the scaling of it vastly more efficient. They are proactively building the capacity that forces adoption rather than, waiting for decentralized market forces to justify the investment.
So the core takeaway here is that the license plate in Beijing represents a governance system that just prioritizes execution over everything else. Unified policy and massive preemptive infrastructure investment create the necessary runway. Now, if that runway is built, what kind of economic acceleration is happening on it? Let's talk about that. Section 2, the economic and scaling advantage.
Right. The economic implications here are massive, specifically in logistics. Autonomous delivery systems tackle the primary operational expense in modern commerce, which is last-mile human labor. Our analysis shows that by automating this process, companies could reduce their overall delivery costs by up to 2/3 compared to traditional human-operated methods.
And we're not just talking about cutting salaries here. It's about optimizing rights, eliminating the costs from human error, and enabling 247 operations. By minimizing reliance on human labor, companies immediately see these massive reductions in operational expenses, and they gain unparalleled scalability.
And critically, in China, that streamlined regulatory environment means that this benefit is immediately available to everyone.
Right.
Exactly. When the regulations are clear, massive players like JD.com and even the smaller enterprises that feed into their ecosystem can rapidly integrate AV technology. For a small manufacturing company or a local food vendor, democratizing access to fast, reliable delivery without the heavy upfront investment of buying and insuring a human fleet, well, it means they can compete with national brands.
So the absence of that regulatory chaos acts as an industrial booster for the little guy.
For the SMEs, absolutely.
And the cost efficiency data is the clearest way to quantify this advantage. Between 2018 and 2024, China saw cost efficiency savings per delivery. And this is measured as a reduction compared to traditional methods, soar from a 10% reduction up to a sustained 40% reduction.
And in that same period, the U.S. moved from a 5% reduction up to a 30% reduction. So while the U.S. performance is strong, China maintains a solid 10 percentage point lead in savings year after year.
So the key question is, where does that extra 10% come from?
It often relates not just to labor, but to things like insurance costs, the speed of deployment, and the ability to integrate state-supported infrastructure like 5G and V2X without having to incur private sector construction costs.
Is the infrastructure dividend paying off?
It is.
So when we look at the adoption rate versus business sales, the data just confirms that direct connection. China's AV adoption rate surged from 2.0% in 2018 to 19.0% in 2024. And this adoption generated tremendous revenue, with sales rising from, $80 million to $1.8 billion?
That's right. And U.S. adoption grew substantially, too, from 1.5% to 15.5%, leading to sales growth from $50 million to $1.3 billion. The correlation between AV deployment and increased business sales, which is due to efficiency gains, is positive in both regions. However, the greater scale and the faster rate of integration in the Chinese logistics sector means that each point of adoption translates to a demonstrably larger overall economic boost across the entire supply chain.
But the metric that really, I think, crystallizes the difference between a unified approach and a fragmented one is customer reach. How efficiently are these autonomous systems actually reaching the end consumer?
And that's where the high density and the cohesive planning in China really pay dividends. China's customer reach expanded ninefold. It jumped from 5 million to 45 million customers in this 6-year window. And when you calculate the efficiency how many customers were gained per percentage point of AV adoption? China achieved approximately 2.35 million additional customers per point.
Okay, 2.35 million per point. Now, meanwhile, in the U.S., customer reach grew 12.5-fold, from 2 million to 25 million customers, which sounds fantastic on paper, but the scaling efficiency was notably lower. It equates to about 1.64 million additional customers per percentage point of adoption.
And that gap, that difference between 2.35 million and 1.64 million customers per adoption point, that is the cost of fragmentation. The U.S. has brilliant technology and massive market interest, but when it attempts to scale outside of these controlled test environments, it just hits regulatory walls, permitting delays, and infrastructure inconsistency.
And China's system minimizes that friction.
It does. It allows the technology to generate a larger network effect in less time.
And the most tangible, just physical proof of this difference is the hardware itself, the actual machines. China dramatically scaled its deployed autonomous units, the actual robots and vehicles, from 200 in 2018 to 7,000 in 2024.
7,000. Now, contrast that with the U.S. deployment, which, while it's growing, it increased from 50 units to 3,000 units over the same period. Deploying 7,000 units is such a clear signal that China has solved the industrial manufacturing and regulatory standardization challenges that are necessary for true mass deployment. That industrial capability is a defining indicator of long-term economic viability and future market dominance in logistics.
It's not just a lead. It really feels like an industrial chasm when you look at those unit numbers.
Right.
So, okay, we've established that policy and infrastructure fuel the economic machine. Let's move into section 3 and dive into the specific technological choices being made and how those are influenced by these different governance styles.
Right. When we're analyzing the technology being deployed for last-mile delivery, we see a crucial bifurcation. You've got air autonomous vehicles, which are drones, and then you have ground autonomous vehicles. Drones offer these distinct speed and sustainability benefits. They fly over the gridlock that paralyzed your acquaintance back in Palo Alto.
Right.
And the research shows that drone delivery achieved up to a spectacular 90% cost reduction by 2024. This is particularly true in expansive rural zones where traditional delivery is just highly inefficient and expensive.
A 90% cost reduction is. That's transformative. But drones face huge technical hurdles, right? Mostly weather dependency and these massive regulatory walls because of strict airspace restrictions. In the US, the FAA requires complex and often really slow certification processes, which means you need physical separation from manned aircraft, and that limits operational flexibility.
And this is perfectly illustrated by the case study contrast between JD.com and Amazon Prime Air. JD.com, operating in China, has focused on a very practical, application-first approach. They're rapidly iterating and scaling their drone systems, specifically targeting remote and rural areas, and they benefit directly from government policies that are designed to solve logistical bottlenecks in underserved regions.
Right. And then on the other side, you have Amazon Prime Air, representing the US approach. They've received federal approval, but the deployment remains constrained by these prolonged testing requirements and regulatory scrutiny. The difference is so clear. One system emphasizes pragmatism and rapid scaling to meet existing needs. The other emphasizes extensive, slow, often litigation prevention testing, which just delays time to market.
Exactly. And then you have ground autonomous vehicles, which are really the backbone of high-density urban delivery. They offer superior payload capacity and much better route flexibility, which is crucial for batch deliveries in cities. Ground vehicles are achieving substantial 70 to 75% cost savings.
And their great advantage is leveraging existing infrastructure, isn't it? Roads and sidewalks with minimal modification. That has to accelerate deployment timelines dramatically.
It does. And the contrast here, again, it just highlights the power of an integrated ecosystem. Meituan in China seamlessly integrates its delivery robots into its massive real-time food delivery platform across all sorts of varied urban settings. They are utilizing that smart city infrastructure, the 35,000 kilometers of smart roads that already exists, which ensures connectivity and minimizes sensor confusion.
Whereas in the US, companies like Starship Technologies have excelled technically, but their deployment is still largely confined to controlled environments like university campuses, maybe some corporate settings.
Right. While they're technically effective in those predictable conditions, it reflects a very cautious, localized deployment strategy. They can't immediately access the broad urban integration that we see in China because the supporting public infrastructure just isn't universally present, and the legal right-of-way for a sidewalk robot can vary from block to block.
And this speed of implementation, it leads us to the core divergence in the governance models, the impact of industrial policy. China's technological momentum isn't random. It's supported by these coordinated, synergistic efforts between government planners, academia, and private tech firms.
Yes, and this rapid integration allows them to scale sophisticated systems like AI-based decision-making and real-time route adaptation that really depend on cohesive 5G-enabled logistics networks.
The comparison becomes even sharper when you look at the electric vehicle sector, the EV sector, which is so deeply linked to AV development.
Oh, absolutely. China hosts 129 domestic EV brands. Now, that number is unsustainable, consolidation is inevitable, and projections suggest over 100 of them will fail by 2030. But this fiercely competitive, state-sponsored environment forces survival to hinge on speed, innovation, and aggressive pricing.
It's like a mandated Darwinian economic evolution.
That's a great way to put it. And it's mandated and supported by national policy.
And this kind of high-stakes, aggressive evolution relies on the existence of long-term consequential industrial policy.
No.
That is what is so difficult to achieve in Western democracies that are constrained by short election cycles.
Right. When opposing political parties gain power, they are often incentivized or even mandated to defund or completely reverse major infrastructure or tech projects started by the previous administration.
Just for political gain.
And that political volatility forces the private sector to pursue shorter-term, lower-risk goals. I mean, why invest billions in a national AV infrastructure roadmap if a new administration could just pull the regulatory rug out from under you in 2 or 4 years?
You can't.
So the state-sponsored capitalism model, by insulating these technology goals from immediate political swings, it allows the leadership to focus relentlessly on long-term national interests. And that leads to strategic dominance in future technologies like batteries, EVs, and last-mile logistics.
And this rapid commercialization model, it isn't just unique to mainland China, is it? We're seeing other high-capacity East Asian nations adopting very similar mobility roadmaps. It reinforces the idea that this is a technocratic approach to engineering modernity.
Yes, look at South Korea, for example. They've clearly defined their mobility innovation roadmap. Korea targeted becoming one of the first countries globally to commercialize Level 3 autonomy for passengers, and they are aiming for Level 4 autonomous passenger vehicles by 2027.
And just to clarify for everyone listening, Level 3 autonomy, which Beijing just licensed, means conditional automation. So the vehicle handles all driving tasks under specific conditions, but the human driver has to be ready to take over when they're prompted. Level 4, or high automation, means the car can handle all driving tasks entirely within a defined operational domain, like a specific city zone, and if it hits a limit, it safely pulls over without any driver intervention.
And that strategic choice to focus on L3 deployment first is such a crucial step for commercialization. It bridges the technological gap while solving the immediate regulatory bottleneck of who takes liability.
That's the key.
Exactly. And South Korea's plan involves introducing comprehensive new regulations, revising existing ones, and aggressively establishing infrastructure for both autonomous cars and urban air mobility, or UAMs. They're even aiming to be the first to commercialize UAM services between Seoul and major airports by 2025. This entire regional pattern just confirms that accelerated technological advancement is strongly correlated with strategic governmental roadmaps and high state capacity.
So this brings us to our final section, strategic implications. We started with the Palo Alto coder debating the hypothetical trolley problem while Beijing was out there issuing licenses. What does this massive divergence in implementation velocity mean for the global power structure and, industrial competitiveness?
It means that a definitive global lead is being established in a sector that will redefine global logistics and urban life. The rapid adoption and industrial scaling in China, fueled by those unified policies and that monumental infrastructure investment, 35,000 kilometers of AV roads by 2024, it establishes them as the industrial benchmark.
And the economic gap isn't static, right? It's widening dramatically. The overall market size confirms this. China's last mile delivery market reached, $4.37 billion by 2024, and it is projected to grow nearly fourfold to an estimated $15.98 billion by 2032.
Almost 16 billion. In contrast, the U.S. market, though it's certainly robust, it lags significantly. It was valued at $1.0 billion in 2024 and is projected to reach $7.10 billion by 2032. So while the U.S. growth rate is healthy, the sheer scale and projected market size for China just demonstrate an economic dominance that's rooted in execution capacity.
And that capacity becomes a self-fulfilling prophecy, doesn't it? It attracts more investment, more talent.
It does. The lesson here is that speed of execution becomes a long-term economic asset. The ability to deploy AVs efficiently in high-density areas first means that Chinese companies are accumulating more real-world data faster, which continuously improves their AI systems.
Generating a constant feedback loop that further cements their lead.
Precisely. And the U.S. faces significant economic headwinds from this regulatory fragmentation and the infrastructure gaps, which directly limit those economic gains, especially for smaller businesses and innovative startups. So we need to look critically at what acceleration actually requires.
Well, the foremost lesson for any nation facing this kind of fragmentation has to be the critical need for policy alignment to unlock the full economic potential. The first, most foundational step for acceleration has to be developing a unified national regulatory framework.
Standardizing rules across states for both drones and ground vehicles would immediately reduce compliance costs and accelerate deployment. And this isn't just bureaucratic simplification, it's economic democratization.
It would enable SMEs to adopt AV technologies much more readily.
Absolutely, especially if we adopted a centralized federal oversight model for AVs, something similar to the FAA's oversight of aviation.
Okay, second, the infrastructure gap. That's non-negotiable. That difference between 35,000 kilometers and 10,000 kilometers just cannot be ignored.
No, we have to prioritize massive public investment in smart infrastructure, widespread 5G networks, and dedicated AV corridors. And crucially, this has to extend beyond just the major cities and into suburban and rural areas to truly enhance national scalability and operational efficiency.
And third, we need to focus on accelerating that crucial transition from advanced research to commercial deployment. The U.S. is a powerhouse of research. For instance, we have these highly advanced systems like NLTA or nonlinear learning-based tracking adaptive algorithms.
Right. These are sophisticated control systems that allow autonomous vehicles to handle highly dynamic and unpredictable traffic flow with greater precision than traditional reactive control models.
That sounds like exactly the kind of innovation the coder in Palo Alto is working on. But what keeps NLTA algorithms and similar cutting-edge research trapped in the lab?
They stay trapped because they need vast amounts of real-world operational data within a standardized environment to move from research to certified production. We need to foster aggressive public-private partnerships to move these sophisticated systems from research papers to real-world deployment quickly, closing that capability gap with China's integrated 5G logistics networks.
Because if the infrastructure isn't there, and the regulatory path is unclear,
then the sophisticated algorithms just cannot achieve the necessary time in market to mature.
And finally, a pragmatic approach requires promoting hybrid AV models.
Yes, this means encouraging combined drone and ground vehicle solutions. You leverage the strengths of each system. Drones for their speed and ability to reach difficult locations, and ground vehicles for their superior payload capacity and all-weather reliability. This combined approach optimizes overall efficiency and provides the flexibility needed to address all logistical needs across varied terrains and weather conditions.
So the core lesson we can draw from charting this whole global divergence is that rapid, large-scale technological adoption hinges fundamentally on achieving robust state capacity, specifically unified policy creation and massive preemptive infrastructure readiness.
Exactly. The philosophical debates we opened with are really a secondary concern until the engineering challenge of deployment is overcome. China's implementation model just demonstrates that strong, stable government backing, clear regulations, and strategic infrastructure investment create a powerful positive feedback loop. Technological progress drives commercial necessity, which in turn leads to further policy support, fostering this self-reinforcing dominant economic position in what is rapidly becoming the critical sector of global logistics, autonomous last-mile delivery.
And the data just confirms it. The ability to scale infrastructure and simplify policy decisions is the single decisive factor in this new industrial competition. Technological leadership is now fundamentally tied to the political capacity to execute massive, long-term engineering visions, moving the focus from code debates to concrete execution.